Okay, continuing on from last video, just quick things change. Forgot to change that to a Y, and this should be square brackets. Okay, so now we need to check our building ID. So to do that, we'll do an if, and we'll go building ID minus offset buildings modulo, which returns the divide from which returns a remainder from a divide, and then modulo of buildings, and then if that is greater than or equal to in buildings, so these are just the parameter names of that. Of these. So if this is true, we want to continue to the next loop, because it shouldn't be one of these buildings. Okay, now we need to check include buildings. So we go if again. Actually, for that, let's make an int called include, and that's equal to 0. So by default, it's not included. Okay, then we need to go find, and it's going to be an array and a target. So an array is our include list. So this one up here. And our target is our building ID. And this will basically return the position in the array if it finds it, or it'll be a negative number if not. So if it's a positive number, then it is included. We'll set include to 1. And now we do a null if statement that basically says include if that equals 0, and then we'll do a bunch of other checks here. Otherwise, we'll skip all these checks because we know we want to automatically include this building. Okay. So now let's check ignore buildings. So let's just copy that. And instead of include, ignore. So same thing. If we find it, we want to ignore. So now we go if ignore is equal to 1, and then continue. Now we need to check must have tags. So these are tags that our module has to have, or our building has to have for a module to go on it. So let's make a new int. It's going to act as a boolean called failed. It starts off at 0. And we go for each. string, and it's going to be a tag, and this is our must have tags. So if find an array inside an array and panel tags the current tag we're looping over. So if we don't find that, meaning it's returns a value less than 0, failed equals 1, and we need a break, which will just entirely stop this for loop. Now we can go if failed equals 1, we can continue onto the next loop, which will be checking the next module because this one has failed. Okay. Now we need to check our must not have tags. And let's copy this. Must not have tags. Check our same thing, check our panel tags, except we want this to fail when we do find one. And then we can just paste that in. Okay, so this is kind of checking all of our conditions. Now we need to check if our module has room to be placed. So let's make another int that will also act as a boolean. The module has room, and it's currently set to 1. So now we need to do a for loop, and this is going to iterate along x, and our count will be module scale dot x. And now we do another for loop, and this is going to be y, and this will be module scale dot y. So essentially what this will do, this will break modules that are larger than one panel into individual panels and check each of them, and if they all work out, then it will be able to place it. So we go if, and the first thing we need to check so we need the index, and then we need a plus x to move it along, and then also plus and in bracket x modules times y, which will be our basically floor we're on. So x will move it along, and this one will move it up. And that's why it was really important way back when we set our point numbers, so they count in a very specific order, so this will work consistently. So if that equals 1, which means if you remember up here, that just means it's assigned, 1 if assigned. So this will be our first thing that breaks it. So this is our check if blocked. Now, we need to do another one. So I got my closed bracket on that. Get rid of that one. Okay. So now, it's going to indent this a little bit. Do vertical slashes, which means or. So if index plus x, so now we're going to check if the module was basically, say it's trying to place one that's 3 wide here, if it's moved off the edge, that's the next thing to check. Okay. So if index plus x modulo x modules equals 0 and x does not equal 0. Cool. So this will be check if module is moved off the grid. Okay. Now, the next one, I'm going to check the top floor padding. So we go index if that's greater or equal than x modules times y modules minus module scale dot y plus 1 minus our top floor padding. And this is check if, or check top floor padding. Okay. Now we need to check if our min floor, so current floor, if that's less than min floor, check min floor. That one's easy. So what's the next one? Current floor greater than or equal to max floor. Okay, so that should be all of our checks. So if it's this, module has room should equal 0 now. And as soon as it equals 0, we can break. We don't need to keep checking because it's already failed.